I'm realizing in making these videos, I don't think I told you that I updated the notes a bit between the time that I printed them for you and in making the solutions. So yours probably reads a bit differently. So it's good that we're here together and you can see my hints. So we've got a economic model example now, and I don't know if they would actually give you an economic problem because not everyone takes econ, and really, if they give you a cost function and then ask you, uh, and then tell you that the demand function, you would need to know that revenue is X times the demand function. And then you would need to know that profit is revenue minus cost. This one I would assume that everyone should know. Like, profit is revenue minus cost. That's a given. But knowing the demand function and how to turn a demand function into revenue, that part should not be expected to know. But knowing this now, and with me telling you this, we can solve this problem. So use your GDC to sketch those graphs. I'm going to leave that to you. Use your GDC, use Desmos, see what happens. But then we want to determine the production level that maximizes revenue. So revenue is equal to X times the demand function. My demand function is at 10,000 minus 4X. So dr dx is going to be 10,000 minus 8x. So I just expanded that in my head, 10,000x minus 4x squared. So production level that maximizes revenue, set that equal to 0. I'll get 10,000 divided by 8. And then, I don't know what that is off the top of my head. Remember, being good at math doesn't mean that you have to be good at arithmetic. So 1,250, what's our unit here? Motorcycles. Motosci. All right, and now production level that maximizes profit. Well, profit is going to be our revenue function. So I'll just go ahead and expand that. Minus the cost, so minus 0.01x cubed minus 18x squared 10,800x plus, how many zeros is that? 1, 2, 3, plus a million. So 10 to the 6th. All right, derivative of profit with respect to x. Well, I could combine these. I've got my 10,000 here and then 10,800 here, so that's 20,800 minus 8x squared. Did I distribute my negative? No, that should be a plus because I was subtracting my cost. So negative, positive, negative. And then that would also be negative. So 10,000 minus 10,800 is going to be negative 800. So let me update that. Minus 8x squared. Again, I could have collected my like terms, so that would be 14x squared. So then that's going to be 28x, and then minus 0.03x squared. All right, so I think I did that correctly. I have a quadratic, so setting this equal to 0, I'm going to use my calculator. This time I'm going to use polysimult. All right, I've got a quadratic. Negative 0.03, 28, negative 800. And number of motorcycles is going to be 903 or 29. So we can't make 903.8 motorcycles, and we can't make 29.5, so I'm going to round down. I could also go back and check this by plugging in and seeing which one is going to give me the maximum profit. So let me go back to main and quit. All right, and let's go ahead and do 903, store that as A, and then I could do my profit function, 10,000 A minus 4A squared minus 0.01 . Okay, so knowing that if I had 903 motorcycles, this would be my profit. If I change my A to be 904, there's my profit. So I can see that, oh, the 904 does actually make more. So I would say 904. Let's check and see what happens when I have 30. Because I can't have, well, all right. Because I need to have a whole number of motorcycles, I want to check all of these options. So let's see which one gives us the most. Okay. Well, definitely not 30. It looks like 30 gives us the minimum, not the maximum. So we want to make 904 motoci to maximize profit.